The following is the video solution from JSDT Solutions. Question 3.1 says, the following geometric series is given and this goes to 15 terms. Write the series in sigma notation. So to write the series in sigma notation, we need the general formula first. So because they said to 15 terms, then this starts at term 1, 2, 3, and then all the way to 15 terms, meaning n is equal to 1. It starts at n equals 1 and ends at 15 terms, so at n equals 15. So let's just find the Tn formula for this series. Okay, so the value of A is 4, and the value of R is, so 36 divided by 12 is 3. 12 divided by 4 is also 3. So the ratio is 3. So the general formula for geometric series is Tn equals A multiplied by R raised to the power of n minus 1. So this is Tn equals 4 times 3 raised to the power of n minus 1. And so written in sigma notation, this is the sum of the series starting at n equals 1, ending at 15 of the series with the general form 4 multiplied by 3 raised to the power of n minus 1, and that is our answer. Question 3.1.2 says, calculate the series. So what is the sum of the series to 15 terms? So we know that it ends at 15 terms, and we're going to use a specific sum formula depending on what the ratio is. The ratio is 3, so this is the value where r is greater than 1. So we're going to use the sum of geometric series formula, which looks like this. So it's A multiplied by R to the power of n minus 1 all over R minus 1. Okay, and of course this is where R is greater than 1. So we're going to substitute our value of A and R and n. So we're saying the sum of 15 terms is equal to the value of A is 4, value of R is 3. So this is 4 multiplied by 3 raised to the power of 15 minus 1 all over 3 minus 1, and let's find the sum of this series. And the sum of this series is 28,697,812, and that is our answer. Question 3.1.3 says, is the series convergent? And we need to provide a reason for our answer. Is the series convergent? Well, look at the ratio. It's 3. Okay, so this series, because it keeps multiplying by 3, the previous term multiplies by 3 to get to the next term, it's just going to become infinitely big. It's not reducing and heading to a specific number. It's not converging. So for it to converge, you see that R was equal to 3. For it to converge, then R should be greater than -1 but less than 1. And you can see from this that this is an improper fraction that we should have. So we see that 3 will not lie in this range, okay? It is not greater than -1, but less than 1. So we can finally just tell them 3 is not greater than -1, but less than 1. Therefore, the series does not converge. Okay, so this R value is not between -1 and 1. Therefore, the series does not converge. And that is our answer. Moving on to the next question. Question 3.2 says, the sum of an infinite geometric series is 13.5. Okay, the sum to infinity is 13.5. And then they tell us that the sum of the same series calculated from the third term is 1.5. Okay, and they want us to calculate the value of R if R is greater than 0. Let's look at the information they've given us. The sum to infinity of a geometric series is 13.5. So this is starting at term 1 all the way to term infinity. Okay, so as we keep going, that sum is equal to 13.5. But then we have this same series, so it's going to also look like we're going to have the same timeline or a similar one. Now, in this series, right, it's the same series. They are starting this time from term 3. Okay, so from term 3, that series, the sum of the series there is equal to 1.5. So here we have the sum to infinity and the sum to, well, it's still the sum to infinity, it's just starting from t equals 3. We're going to have to find a way to express this. So this sum to infinity, we know that the sum to infinity's formula looks like this. It says a over 1 minus r, right? So if it looks like that, you see the variables that we'll have would be a and r. Now here, how can we express this sum that they're referring to? Well, you could say the sum to infinity, this entire section, and if you say minus this part, okay, then you're going to get the sum to infinity from term 3 all the way to infinity. So that's another way we can express it, but we need to find out how do we express this part, because we're going to say the sum to infinity minus the sum of the amount of terms that we have here before the third term. So that is term 1, and then we have term 2, and then that's it. So it's just the sum to infinity minus the sum of 2 terms. Okay, so here's what we're working with. They've given us the sum to infinity minus 2 terms and the sum to infinity itself. We know that this is equal to 1.5 and the sum to infinity itself is equal to 13.5. So this is just going to be a simultaneous equation. Okay, let's go ahead and find the sum to infinity. We know sum to infinity is simply equal to a over 1 minus r. So we'll say this is 13.5 is equal to a over 1 minus r. And I'll just go ahead and make a the subject. So if I want a to be left alone, I need to get rid of this. So we can multiply both hand sides by 1 minus r. And so we have a equals 13.5 times 1 minus r. And now to find the sum to infinity minus the sum of 2 terms. Well, we would need to understand what the sum of 2 terms is. This is a geometric series, right? You could write the sum formula, but there's actually an easier way to find the sum of 2 terms. The sum of 2 terms, given that we don't know what a is and we don't know what r is, it would be, the first term would simply be a, so t1 is a. And term 2, you can just see this as substituting 2 as an end value into the formula, a multiplied by r raised to the power of n minus 1. So you'd say 2 minus 1, which is 1. And so you see that term 2 is just equal to a multiplied by r. So the sum of 2 terms is term 1 plus term 2, which is really just a plus a times r. Okay, so the sum of these 2 terms will equal, so we're just going to take out that common factor of a, and now we have 1 plus r. Okay, so that is the sum of 2 terms that we have. And now we can just rewrite this. So we're saying that the sum to infinity minus the sum of 2 terms is equal to 1.5. And we know the sum to infinity is 13.5. And this is minus a times 1 plus r is equal to 1.5. Okay, so now we can just go ahead and transpose this to keep it on one side and bring the number over. So that's 13.5 minus 1.5, which is 12. So this is 12 is equal to positive a times 1 plus r. And then we can make a the subject. Okay, so a can just be the subject in both. So divide both hand sides by 1 plus r. So that is a equals 12 over 1 plus r. Okay, so now that a is the subject of both equations, we can just equate them. So a is equal to a, and we have 13.5 multiplied by 1 minus r is equal to 12 over 1 plus r. Okay, so now we can solve for r. Let's go ahead and cross multiply. So this has a natural denominator of 1. And so we're saying all of this times 1 plus r. Let's first just rewrite it. So it's just 13.5 times 1 minus r and 1 plus r is equal to 12. Okay. Now we can get rid of that 13.5 by dividing both hand sides by 13.5. But we're going to rewrite that as well. So this is divided by 13.5 and we'll find out what that is. Now 1 minus r and 1 plus r, this is the product of factorizing difference of 2 squares. So that is 1 minus r squared is equal to, and let's find out what 12 divided by 13.5 is. Okay, so as a fraction, that's 8 over 9. Okay, so we know it's 8 over 9. And then we can transpose that to make it positive. So if it's over, it's positive, and that's just 1 minus 8 over 9. So therefore, we're saying r squared is equal to 1 minus 8 over 9, that's 9 over 9 minus 8 over 9, which is 1 over 9. And then finally, we can solve for r. So square root both hand sides of the equation, but of course, we'll have to consider the positive or negative solution. But remember that they said specifically r is greater than 0. So we can also just tell them that. Just tell them, but we know that r is greater than 0. Therefore, r is equal to, and we'll take the positive solution, which is 1 over 3. And that is our answer. Okay, and that is the answer to this question. Moving on to the next question. Question 3.2.2, the last question for question 3 says, hence determine the first 3 terms of the series. Okay, so now that we know what r is, let's find the first 3 terms. So we had expressions for a over here and over here. I'll just take this one because it just looks a little more simple. So we'll take this, and in place of r, so we'll substitute that r value. So a is equal to, so this is 12 over 1 plus 1 over 3. And let's find out what that is, which is 9. So that's 9. And now that we know what a is, here's how we can find the first 3 terms. Okay, so since the first term is 9, to get the next terms, you're really just going to multiply the previous term by the ratio. The ratio was 1 over 3. So we'll say 9 times 1 over 3. And that gives us 3. So it's 9 plus 3 plus, and to get the next term, you'll say 3 times 1 over 3. And that gives us 1. So plus 1. And then that keeps going. So there we go. The first 3 terms are 9, 3, and 1. And that is it for this question.